would be, I'm going to reverse it on you, mix it up. What if the width falls between 0 and 1, if it's a fraction between 0 and 1? Is it going to be wide, narrow, or normal? It's going to be wide. Okay, if the width is a number greater than 1, it's going to be narrow. And if it's a number, if it equals exactly 1, it is normal. Okay, I had somebody ask me a really good question last class. Okay, so if it's -2, does that mean -2 is less than 1? So that means it's going to be wide if it's -2? Does the negative matter? No. On the width, the negative does not matter. The only thing the negative tells you is whether it's going to open upward or it's going to open downward. That's why I'm absolute valuing these. The negative, positives, and negatives have nothing to do with it. It's the size of the number. Okay, what if I told you it was a fraction that was 5/2? It's a fraction, so does that mean it's wide? Yeah, you have to, fraction 5/2 is really 2.5. That's bigger than 1, so it's going to get narrow. So it's the size of the number that you need to be looking at there. Okay, well, what we want to do today is I want to be able to figure out how to find this stuff if I give you the equation in standard form as opposed to vertex form. Because quite frankly, most of the time we work with standard form far more often than we work with vertex form. We just don't. Vertex form is the most awesome for finding the vertex and graphing it. But if you're talking real world problems, you're probably not going to get it in that form very often. So what I want to do is I want to figure out how do I find a formula to find the vertex if I'm in standard form. And to get you to see where that comes from, we're going to perform an experiment here in a second. So we're going to try, if I was to throw you -4 times x minus 2 quantity squared plus 5. That was nice. Okay. I know right now you can tell me where's the vertex on that one. Okay, because it's going to go right to a 5. Okay. I want to turn this into standard form and then see if you can find how do you tell how to do that. So how would I turn that into standard form? Can I distribute the 4 when it has the square on it?
Well, can you do your powers first?
Yes, you would do your powers first. So you would go, oh, yeah, I can distribute this, except we're saving at the moment. They must know you came in. Okay. So yes, I could, how do I square that out though? Well, you have to take it times itself. So can I do, it'd be x minus 2 times x minus 2. Can I do just first and last? Yeah, this is FOIL it all. Sorry. We love to FOIL. So outsides are going to be -2x. Insides are going to be -2x. And lasts are going to be +4. And then don't forget the +5 out there on the end. Before I distribute the -4, I want to combine those middle terms there. So it's really going to give me x squared minus 4x plus 4 plus 5. Or a lovely, if I distribute -4, being careful here, -4x squared, what happens with the x's? Positive or negative? Positive 16x. And we have a -16 and a +5. And then last but not least, I can add the two numbers out there on the end, and -16 plus 5 is going to make -11. So there is standard form for this particular problem. what I want you guys to figure out, I know the vertex is 2. The x-coordinate of the vertex is 2. There is a short little formula that will tell you that by using the numbers here in standard form. And I will give you a hint that it's something over something. But can you figure out what numbers I could take out of here in standard form and come out with an answer of 2? It's just numbers, no variables. Don't take the x's, just take numbers. So somehow I have to get this thing to come out to be a positive 2. So which number do you think might be likely on top? Well, since it's going to come out bigger than 1, it's not coming out a fraction, it probably means the 16's probably got to be up top. The negative 4. Well, if I do that, 16 divided by negative 4 is negative 4. What would I have to do to it to get it to become a 2? I would need to times the bottom times 2. So if I did 2 times that, that'd be 16 over negative 8, that'd be negative 2. So yes, somewhere I need to add a negative in there. They actually throw it on the top when they do it. They actually take the middle number here, the 16, and they change the sign on it. And so now, translate that into symbols. Because this was A, B, and C. So we did negative B, 2, and the negative 4 came from A. And ta-da! You have just discovered the formula for how you find the vertex in standard form. It's negative B over 2A. So let me go back and put that on our formula page here. You now know that if you are wanting to find the vertex and you're in standard form, you get the x-coordinate by doing negative B over 2A. Okay, then how are you going to get the y-coordinate? Okay, in this case, that's kind of a fluke that happened. She said 16 minus 11 will get you the 5. That's actually not what happens. That's kind of freaky that it works there. That's not normal. Sorry. But if you know x, yeah, can't you just fill it in? You'd find y. I can just fill in x right here, and I'll find out what y is. So yeah, all you have to do when you want the y-coordinate is just sub the x-coordinate into the equation. That's all it takes. So you have to remember the negative b over 2a, but then it's just a matter of subbing the number in, you'll get your y-coordinate. Will the rest of this stuff change? Can I still find the direction by looking at a? Will we still know whether a was a positive number or a negative number? Yep. So you can still get the direction by looking at a, that first number. The line of symmetry, it's still h, it's still that first coordinate. So yeah, the line of symmetry is still going to be, I mean, if you want to write it out as the way we did the other day the first time, it's going to be x equals the x-coordinate of the vertex, whatever you got for the x-coordinate of the vertex, that's where the line of symmetry is going to go. Is the width going to change? You can still look at a, the front number, to decide whether it's going to be wide, narrow, or normal. So the only thing you really have to do differently, whether you have vertex form or standard form, you have to manage to remember negative b over 2a. The rest of it pretty much follows exactly the same. So that's the good news. Now that you've done that, let's go see if we can do one. I had something going the wrong way. I'm top. Go back. There, nope, one more. There's our nice little problem. Now, last class, originally I had an equal sign in this, and then they wanted to do some more with inequality, so I threw an inequality in there, but it doesn't matter whether it's inequality or an equal sign. Okay, so I want to find all the parts and draw the graph of this puppy. So the big question is, I need a vertex. And we just discovered that you get the x-coordinate by remembering what? Now, it is really key that you have, of course, have this in order. So make sure you've got an order, squared term first, then first power, then constant. You got to have it in order. So in this case, a negative b would be what? Negative 6. Okay, if that had been, say, a negative 8, this would have been positive 8. You always switch the sign on that term. And then do 2 times a, which in this case a is negative half. Why is that actually nice? Yeah, don't you 2's cancel? You have negative 6 over negative 1. It is positive 6. So we have the x-coordinate of the vertex is positive 6. Okay, that's the hardest thing to do. How do you get the y-coordinate? Yeah, sub it in for the x. Forget the fact that that's a less than for the moment. You're literally just subbing in 6 squared plus 6 times 6 minus 15. Okay, now try not to break order of operations. 36 times a negative half, that's negative 18, plus 36 minus 15, and we need to add all that up. And assuming that we actually are going to do this without our calculator, add the 2 negatives together. That's negative 33. With a positive 36? Yeah, your 3's right. 6 is 3. So now, write as coordinates. What's my vertex? 6, 3 would be your vertex. So we actually then, if we're going to graph it here in a second, we now know the vertex is 6 over and 3 up. Because I want you to practice, we're going to do these other things. All right, tell me, before we graph it, is this one going to go up or down? It's negative up front, so yes, it's going down. The line of symmetry? How do I write it? Thank you. It's the vertical line. X equals 6 because it goes through the x-coordinate. And then, is this one going to be wide, narrow, or normal? If it's a half. Half is a fraction, that makes it wide. Okay. Now, the good news. We need to graph this and find your points to plot it exactly the same way you did yesterday. No change. Do identically the same thing. As long as you know where that vertex is, the other points are still going to do the 0, 1, 2, 3, and then what was always the other side? Yeah. 1, 4, 9, your friends. Do I need to change the 1, 4, 9, or do I just leave them? Since there's the half, the negative half, you would need to change all the y-coordinates, take them times the negative half. Which would make a negative half, a negative 2, and a negative 4.5. So that part does not change. It's identical to the way you did it before. So if I go plot that, from this new vertex we plotted, we would weave 1 over and a half down on each side, 2 over, 2 down, 3 over, 4 and a half down. Now, since I hung an inequality on this one, dotted or solid? Got an equal sign, so this one's solid. And then, where to shade? So, it wants y-coordinates to be less than the graph. So I would pick the vertex where y coordinates that are less than. Down. Y coordinates are less down, so it would be everything inside on this one. Okay.